Hello everyone, this is David. Welcome to my YouTube channel where I'll be explaining various figures. I'm sure you have all been exposed to different mathematical constructions, especially those related to geometry. We have all been required to construct lines, to construct circles, to construct triangles, and all that, and to bisect angles. There are very many activities in the geometry class. So for this one, we are going to use GeoGebra. And before we proceed, I would request you to subscribe so you don't miss the next videos. Also, if you, in the course of the class, if you have any question, you can comment, and then I'll work on that. Maybe I'll uh, upload new videos related to your suggestions. So going on to our topic today, we have the three types of uh, circles. So we have the first one inscribed. This is the circle that is drawn inside a triangle, touching on the three sides, the three inner sides. So everything about inscribed, you'll notice that the circle is found inside the triangle. And then if we go to the circumscribed circle, this is the, it should be different. This is the circle that is drawn touching the edges or the vertices of the triangle, and they have to touch all the three vertices. And then we have an inscribed circle. This is slightly different from the two, and I will explain as we proceed. So we're going to start with just any triangle. So I just create any triangle, triangle ABC, that way. So we have our triangle already. For the clarity, I want to make uh, my triangle, there's a different color so that we, in the course of the construction, we won't get mixed up. So use color black for that. So first of all, according to this triangle, we have three sides. We have side AB, we have side BC, and we have side AC. So you will notice also we have three vertices. So we have vertices at A, B, and C. And that means at every vertex, we have an angle that will come to play later. So if we are going to start with an inscribed circle, we need to note that, illuminate something here just for your go through. So the inscribed circle, you can see that this is obtained by bisecting the three angles of the triangle. And also we can also add that the point of intersection of the three bisectors from the center of the circle. So having that, you can just place it where you will be able to see it well. Let me drag it up to there. So at least everything we have is visible. So first of all, if you're going to bisect the angles so that we can get the point of intersection of the bisectors. So I'm not sure if you have been through bisecting, but I know if you are uh, past the high school, you must have done this, or the middle part of the high school. So if you want more more skills on the bisecting using the compass, that is if you don't know, if you are not familiar, you can comment and I will upload a video simplifying the bisecting of both the angles and the lines. But for this class, we're going to use the GeoGebra tools so that you can be able to see it clearly. So first of all, we have seen that we have three angles. We have an angle at vertex A, we have another angle at vertex B, and another angle at vertex C. So we want to bisect these three angles. We can choose three or we can use two because provided they intersect, provided the two lines intersect, even if we add another third line, it's going to intersect at the same place. So going to the bisection of, you can start at A. So just come and select the angle bisector if we are using the GeoGebra. So bisecting with the angle at A means that we'll be dealing with the angle CAB. So as you can see, we have the angle bisector. So that means that it divides the angle at vertex A into two equal parts. We can do the same for the angle at vertex B. So we have A, B, C. So as you can see, let me introduce a line here, a point. You can see that it is meeting at this point. This is the point of intersection of the two angle bisectors. So even if you are going to add the third one, let's see if it will meet at the same place. So we go back to the angle bisector. So now, because we are dealing with the angle at C, so we have ACB, and as you can see, we have a common point of intersection of the three bisectors. So you can choose two, but you can also go for the third angle. Since our lines are very long, I need us to trim them to shorter ones. So we can trim it there. In the same case with this one. And then the last one too. So this is just for clarity. And also since I want it to be easy to differentiate between the three, since we may be, I don't know if which is better, if we can use the same triangle or we can use different triangles. So if we're going to use this triangle, what we can do is that we can make sure that for the inscribed circle, circumscribed circle, and ascribed circles, we use different colors of what we have used, the bisectors and the circle itself. So for example, for this first one, the inscribed, we can choose the color green. So let's use green bisectors. So we have those three. Okay. So this is the third one. So now if you get to this point, now it becomes easier. So if you are using the compass, you have to make sure that the pointer is at this point D, and then the pencil tip is at any side, any side that you choose, provided that it you make sure that the circle does not get outside even a single part. So you can either side, provided it does not go beyond the three lines to the outside. So we have our circle. This is our inscribed circle. So as I said before, I want us to use the same color. So you can see our inscribed circle is green. I think we can write it somewhere so that it will appear like a key. So we can say that inscribed using the color green. And then we go next to circumscribed. We can use color red. So this is just the key. This is just for you for easier reference. Now, if you are going to the circumscribed, no, before you go to even the circumscribed, uh, in most cases, if you are told to draw the inscribed circle, you'll be asked either the radius or the diameter, because that is what they will use to assess whether you got it right. So, sorry. So if you're going to find the radius, we want to have 2 points. So we have the center, which in our case is D. And then you have to choose anywhere where the circle touched any line. So you can choose L there, can also choose here, or you can choose any other point, maybe even here, because already you have the circle. So if we're going to measure the radius, you will notice that the three give the same reading. So let me use this one. So the distance from D to dm, yeah, so we have the radius being 4.6, in our case, centimeters. The same way, if we choose D and N, you can see it's the same. Also the same for DL. Yeah, so provided that you start from the center to any now part of the circle, because you have already drawn the circle considering all the important guidelines of the bisectors. So nothing will be wrong. So since we are not using this, we can just delete them. So yeah, I'm not using that one, and this one too. So another thing maybe we can do is to have the distance so that we can know our triangle measures what centimeter by what centimeter. So we start with, say, AC, or say that is 14.1. We go to AB, that is 17.1. And then finally we have BC, which is 19.5. So since we have covered now everything about the inscribed circle, now we can go ahead to the circumscribed circle. So under there, we just add another point down here. So we are now at circumscribed circle. And as I said earlier, this is a circle drawn touching the vertices. And now about obtaining it. So we have obtained by bisecting the three lines. So you notice that in the inscribed circle, we are bisecting angles. But now for the circumscribed circle, we're going to be bisecting the three lines. And then the intersection point gives the center of the circle. So as I said before, you can either choose to have one, maybe you can either choose to have 2 points or 3 points because they'll give you the same thing. So we said that for the circumscribed, we are going to use the lead color. So let's proceed. So here now we are dealing with bisecting the lines. So we need perpendicular bisectors. So in the same way, if you'll be using the compass and you need help with that, make sure you either comment or you reach out to me. My email is in my channel, so we can plan on what to do. So let's proceed now. So the perpendicular bisector, we will start with our line AB. So we have A, B. So we have that one. And then if we bisect BC, we have our point of intersection right here. Let me first of all tap it. So we have this the intersection point, point O. And now if we're going to try the third line to see if we have the common intersection, we have line A. So we want the bisector. It's right here. The bisector of AC. You can see we are arriving at the same point. And now before we proceed, because the lines are so extensive, so we need to shorten them. So we start with this one. And then we have this one here. And then the last one. So you have the three of them. And also we talked about the colors. So we want them to have color red as a grid. So color red, and this one color red. So now we have our intersection point of the three uh, perpendicular bisectors. So these were just bisecting the lines. So, and the bisectors, as we said, they cut what they are bisecting into two equal parts. So if you are going to bisect, for example, line AC, which is 14.1 centimeters, so you expect that every side to be of equal size, of equal length. So let's proceed with the drawing. So when you're using the compass, so your tape, the pointer, should be at this point. This is the center O. And then the pencil part can be at any edge, any vertex. So if you choose B, or if you choose A, or if you choose C, they will all give you the same answer. So provided you have the right bisectors, and now the distance between O and now the circle is the radius. So for this case, we can use the distance being the radius as the distance OB, OB here, can also say OC. or OA, it will give you the same answer, the same radius. So let me just measure one so that we can have the reading, the radius of the circumscribed circle. So we have OB being 10, and if you can try OC, you can see it is still 10. So we are not going to use OC, one is enough. So let's just take it out. So now you have the circumscribed circle. And in the same way, we said we need it to be red. Mhm. So we just need to come to the color, and then we follow what we said. So up to there, I hope I'm clear. So now we can go to the third one, which is the ascribed circle. Now this is a little bit complex, so it needs your attention, but the moment you master it, it becomes easier. So I will explain it in the simplest terms possible so that it can be easier for everyone to understand. So an ascribed circle is a circle, you can say touching one side or one line, maybe if it's side A, C, side C, B, that way. So one side of the triangle. And this word is new now, the extensions of the other lines. I will explain so that you will see how easy it is. So this one is obtained by bisecting the interior angle of the side of or of the vertex opposite the side where the circle is supposed to touch. So that is one point. We may use 3 commas. And then later, bisecting the other two, later bisecting the exterior angles of the other two vertices. So basically what I'm trying to say here, this did not go as I wanted. Let me try to make it appear well. So I don't know. And later. Yeah, I wanted it to fit here. So we won't have any issues outside here. So what I'm saying basically is that, for example, if now you are given an instruction, you are told you draw an ascribed circle touching on the shortest line of the triangle. So in our case, the shortest line, as we can see from the measurement, we have 14.1, 19.5, and 17.1. So the shortest is AC, so which is 14.1. Now we want to draw a circle which will touch this line. So it should come this way. And now it will also need to touch the extensions of the other two lines. So what I'm trying to say is that we need to, if it is going to touch this line AC, and the extensions of the other line. So we need to extend. We need to extend the lines AB. So AB, and since we expect something like this, so obviously we're going to extend it this side and this side. So let me reduce the size. Mhm. First, this one may be a little bit big, considering what we have. So let's just extend it. So we have, so if you're using a pencil, it's much easier because you just need to use a ruler, and then you ensure that this line extends to this, to any length. And the same way, the line BC. So just make it extend this way. So for my case, I'm just gonna use the segment. So I just need to make it longer. Let me press it at that. The same way with this one. So as you can see, these are the extensions of the other lines. And then this is the line that the scribed circle is instructed to touch. So now, as we said, we are going step by step. So it is obtained by bisecting the interior angle of the vertex opposite the side. So if the side of our interest is AC, the opposite interior angle will be this one. Will be angle ABC, the angle at vertex B, right? So we're going to first of all bisect that. Let me move this one. So we need a new color for for this Escribed circle. And we can add touching side AC, which is the shorter side. So let's use blue. Yeah, that's okay now. So first of all, these are just the lines that we had previously. Our triangle, this is just an extension. So we are not going to change the color. So now let's start with bisecting the interior angle at the opposite, which is B. So the same way we did in the first part, just need to bisect the angle. So it's angle ABC. So we already now have this one. And now, since I want it to be a little bit short, we just shorten it so that it is easier to see. And also, we talked about color. So before I proceed, I want this one to go step by step. So we need the color to blue. Let's use the dark blue or the blue. I'm not sure the color, but it looks like blue. So we have the first bisector of the interior angle. Now, if we go to the second instruction, later bisecting the exterior angles of the other two vertices. So what this means is that the angle at A, the interior angle, is BAC. This on the inside. I know you have noticed that because since we extended this, we have this angle, and now we have angle CAV, which is our V here. So these two angles must add up to 180 because this is a straight line. So if you are talking about the exterior angle, in our case, it will be CAV. So we want to bisect that. And the process of bisecting is the same. If we're using the compass, it's very easy. I can walk you through that. So we want to bisect CAV. So we have that line, which is the angle bisector, but now of the exterior angle at A. So let me shorten this for clarity. So I'm going to, don't need a very big length. Sorry. So I just need to take it from here. It's not doing what I want. Let me just cut it from here up to this point. You don't need a long one, provided it has already done the task we want. So for this two, you can notice that we already have an intersection point, which is this point here. This is where they meet. And so this is a point. And before we proceed, let me make this one in the color we agreed, the blue or the dark blue. So we have the two. And now I want us to now bisect the other exterior angle at C. So you may ask yourself, at the other vertex, which is C, the interior angle, which is it? Because you need to have a clear understanding of the angles. So the interior angle is A, C, B. So this is the interior angle, this one here. And then we have the exterior angle being A, C, now W. This is the big angle here. So if we're going to bisect this, we just want to say if we have a common point. So this tells you if you are accurate, you can use only 2 points, only two bisectors. But it's good to use all the three of them because at some point, if you get maybe uh, the three bisectors, maybe one is not meeting at the required or at the common point, then you know that you made a mistake. But now, if you use two, and then maybe you had made a mistake, you will not be sure whether you are right or wrong. So the third bisector will easily try to tell you if you are on the right path or not. So we go to angle bisectors. So we need to bisect the exterior angle at vertex C. So this is angle A, C, W. So as you can see, our bisector is at the right point. That is where we want. So we just need to shorten it. So we shorten it and then we change the color to Escribed. So blue, which was agreed. And now we just need to draw now our circle. So if you are using a compass, as I said, make sure the pointer is at this point. This is D1, which is the center of the now Escribed circle instructed to touch side CA. So before I do that, Let me take this one out so you can see it well. I want to move this label CL so you can see where the circle touches. So we can see if we did the right thing. So this is the center. And then we want it to touch. As you can see, it's now touching there. So we have now our circle. Let me give it the correct color, which was agreed. So we need our blue. So now you can see that our ascribed circle, which was instructed to touch uh, the shortest line, which was AC, it touches very well. And then it also touches the extensions of the other two lines. So we can see this is the lines we extended. It was AB, but now we extended so that we have a lengthy one. So it's now BAV, and then we have BCW. So we just extended them so that we can see whether the scribed circle is going to touch the uh, these extensions or extended lines. So in the same way, if you're going to get the radius, let me let's measure for you. So for this case, we shall have C. Uh, so we have D1 and any other. So we can choose any point. So I just need to first of all create a point. So let me use any point on the circle. And then we measure the distance, which is D1, H1. So we have 10.5 as our radius. The same way, D1, I1, it's give you the same. So since we don't need multiple, you just need to delete one. But now I believe you have gotten the major concept. Maybe for, what do we do? If you want more understanding, you can just get me anywhere, especially on the email, on the comment. But most importantly, make sure you subscribe because this is a new account. So I'm just trying to get most of my lessons online, which are taught in high school and college level. So in the as we progress, I plan to ensure that we have enough content for the high school and for the colleges, especially for the courses I'm teaching, that is mathematics, physics, management, engineering, and energy, renewable energy. So maybe just touching on this complex part, as I said, now you can see how easy it is. Just that the instructions may seem a little bit frightening. So I don't know if I can get a new triangle so that we can just draw the ascribed circle only without now considering the inscribed and the circumscribed. So let me just create another one right here. So the polygon, we're just using any triangle. So in our case, we have JKL, but now since we had JKL previously, so this one now is J1, K1, L1. So as we said before, I think we need to change all this to black so that we can maintain the color consistency. So let me just use the black color. So, so we go black, we go black, we go black. So that's it. So as we discussed previously, we said that if you want to, I think I liked something here. So maybe we can do it extensively because this one requires more practice. So I have one and describe circle touching. Uh, let's. I think we should draw like two, two of this, right? So the first one touching J1, K1. So this is just the line J1, K1. Then two, Escribed circle touching. Uh, we can, since we had this side, let's use this side. So this is J, K, L. So we can use KL. So K1, L1. Let me use calculators. K1, L1. So that is okay now. So let me press it there so that you can see it well. And just to edit, since we need different colors. So in this case, I don't know which colors we have. Let me just confirm. We can use, these are so many colors. So since this one is just for verification, let's use something like blue for the first one and the green for the second one. Those colors have so many names which are not easier to comprehend. So we start with blue, and the first one, it's supposed to touch J1, K1. So we have J1, K1 here. So as you must have guessed, since this is the line of interest, we need to bisect the angle which is opposite. And opposite is like drawing the perpendicular bisector this way so that you can get the opposite, which is L1 now. So now what we shall do, we just need to bisect this angle. And this is the interior angle, this angle here, as you can see. So we just need to bisect it. So angle bisector. So we bisect J1, L1, K1. Then since we don't need those long lines, we just trim it. Okay, we may not trim it up there since we don't know where the center will be. Let me just make it longer. Okay. And the reason why it extended to this side more is because the ascribed circle is expected to touch uh, this line. So it's supposed to come maybe like something like this is without getting inside. So that means our center must be on this side here. So we have that one. And we said about the color, the first one is supposed to be blue. Sorry. So we have this one having blue. And then we can we need to now extend, and something must have told you that now we need to extend which lines. So for this case, we need to extend the other lines, which is L1, K1, and L1, J1. So let me drag it so we can be able to extend. I don't know if it will touch the other one. So let me move this one too, maybe to somewhere so that we can be able to extend. So we have L1 here. So we extend it. This may be somewhat wider, but we shall see. And then we have L1. Okay. I think I drew one which is very sharp, but it's okay. We'll know what to do when we get there. So we'll make this one longer, maybe up to somewhere like that. So, so as we know, the interior angle, this is one, and this one here. But now we need now to bisect the exterior angles. So we just go to bisect them. Angle bisector. So the first one, it's at this vertex, J1. So we need to bisect K1, J1, O1. So you can see we are still far. And then the second one also, we have bisecting. This is this one now. So it's J1, K1, K1. So as you can see here, but I need to still shorten them. Let me show you what we'll do. So these are so long. So we just need to cut the sides because our point of interest is on the other side. So up to there, it's good. And then now here, you can just extend it, but I don't want it to, this will not work well. I think the circle is so sharp. So I don't know if it can move. Let me see. So I want to move this way. Down, 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 down. Let me just see. I want it to move as far as possible because I need to zoom it so you can see well. So we have that because the other one, it's much higher. And since we need to, because we had drawn the vertices in the wrong part, let's just select them and just take them all out. So we need this one, this one, this one, this one, this one. Let's just take them all out. And then our circle remains. Not our circle, but our triangle. So let's delete these points. So we had the instructions. So I want to cut them because they are part of here. I want them to be close. So this is it now. So we had Escribed circle touching J1, K1. So this J1, K1. So we were bisecting this angle, which is opposite. So we proceeded. Let me try to move first because we had done this. So we had that bisector. So for this one, I'll not cut them first. I'll cut them after we have confirmed that we have an intersection point. And now we need to extend the other two. Mhm. Let me try to shorten all the angles just to have something that does not go so far. Mhm. So since we have that one, let's extend so that we can have the exterior angles. So we need to extend L1, J1 a little bit further. Maybe like that. The same way with L1, K1. So up to that. So make sure you use a ruler so that you can have an accurate drawing, especially when you want to extend. So we want to bisect now the exterior angles, which in this case, let me try to move faster. We have J1, K1, N1. And also the second one, we have this one here. So we are going to bisect K1, J1, M1. So as you can see, we have a point of intersection here. So at this time, I can reduce my lines so that they stop looking so ambiguous. So since we have the center already, so can stop seeing this one. The same with this one. So this is the bisector too. So we can just take it up to there. And then the last one. So up to there. So I just want the work to be clean. I don't want more disturbances. And then we can see that we chose the color blue. So we have blue. Blue is sorry, need to the first one blue, the second one blue, third one blue. So with that is the intersection. Now we have the center, which is this point. Center is our point W1. So now we can just draw our circle. So remember the pointer of the compass to be at W1. And then you have to touch, make sure it touches the line. Now for this case, you can see where it is touching it. So if you come up to this point, it will not. So you need to find one which is you can even measure, for example, the radius or the distance so that you can see which one fits the best. So if you decide to, since the compass uses a pencil, that is why it uses a pencil, because sometimes you need to erase some things. So for this one, as you can see, it's a different kind of a triangle. So ours touches it at this point. So you have to place the pencil at the line and then try to plot the circle as you see whether it will touch the right point. That is the only way you can be sure for such kind of a triangle, which is different as compared to what we had before. As you can notice, this one, we just made this one up, so it doesn't have to be so disturbing because we even don't have the correct measurements and all that. We did not need to have them. So this was just to ensure that you get the concept. So now we have an ascribed circle touching on the J1, K1. So the main important idea here is that you know if you're going to deal with this line, certain line, you make sure you spot the opposite angle, which in this case, the opposite is this one here. And now you will bisect the interior angle. And then for the other vertices, you extend the lines and then you bisect the exterior angles now, the two exterior angles. Although, as we said, if you are very accurate, you can use one. So that was the first one. So we can go to the second one, the ascribed circle touching K1, L1. So this is K1, L1. So that circle, like this one, is supposed to come and touch this line here. So for this case, we need to now push this one up because we don't need it so much because we have already done with that. So first of all, if we're dealing with this line, so you must have guessed that the interior opposite angle that we need to bisect is this one here. So we need the angle bisector. The angle bisector of L1, we need L1. No, not that one. So angle bisector of L1, J1, K1. So we have this bisector, is the angle bisector, but of the interior angle. And now, since we need an ascribed circle touching line K L1, K1, so we need to extend the other lines. And we are going to do that right now. So I can minimize it right. So we make this one longer. Not make that one. I think this was so short. We'll just take it out from there. It's causing confusion. So I need a segment to continue this line. But then this is where you need to notice the mistakes, because now if you continue with this line, you are not continuing or extending the side of the triangle. You are now extending the bisector, which is a mistake. So when you are using the ruler, make sure you have chosen the right line. So for our case, it's J1, L1. This is the dark line. So if we have a segment, we're just going to extend it. It passes from J1 to L1, and then it proceeds that way. So you just make sure it's very accurate if you're going to use the ruler. So that one. And then we also extend the other one, which is J1, K1. So the same way, we need a segment. So if you're extending, it's very easier when you're using the pencil and the ruler, because you don't have to keep going back and forth. So let me move it where you can see well. So we are dealing with the Escribed, which is supposed to touch K1, L1. Now, as we said, we have already bisected the interior angle, and now we want to bisect the exterior angle at the other vertices. So as you can see, this is our triangle here. This is J1, K1, L1. But that is the interior angle. This is the interior angle here. And what we are supposed to deal with is this exterior angle. So we want to bisect this angle L1, K1, B2, and K1, L1, A2. So we just come back to our bisector. So first of all, we bisect this one, the exterior angle at K1. So we have B2, K1, and L1. So already we have a point of intersection, but for clarity, let's just proceed with bisecting the last point, the last exterior angle. So we have A2, L1, K1. So as you can see, it's intersecting at a point which is C2. So what we are doing here, we just need to follow what we did previously. But before that, I need to shorten these lines because we already have the point of intersection. So we have that one. Then you can also cut this one. And then the last one. So this is the bisector. Yeah. So mhm, let's leave this one because it's intersecting with this other line. Or we can just cut it from afar. No, be from here up to here. So we can just remove the longer one. And then we have to change our colors as a grid. So this was the first bisector, the interior angle bisector, which was opposite. So we chose color green. The second one and the third one. Now, since we have all the points, now we can just expand it slightly so that we can be able to draw the ascribed circle. So you just make sure it is touching the line. So for clarity, we can say that the best way to know where where the length of the pencil, which is you should extend the length of the compass or the radius. If you consider from this center up to this point, you will notice the length of the radius is maybe a certain value, maybe it's 10. And then you measure at another point, you notice it has become shorter, maybe it's 7. And then if you try another point, maybe you notice that it is from the center C2 to the line that is supposed to touch. Now you notice that now it's very short. So you aim for the shortest distance from the center to the line because the moment it starts becoming the radius becoming high, the more you will be losing it. And then if you keep reducing it, you'll notice that at the least, that is where you get the best circle, which you are supposed to draw. Because even if you continue towards L1, you'll notice that it becomes bigger, the radius becomes bigger. So you aim for the smallest radius or the smallest distance between the center, which you have obtained, and the line that it's supposed to touch. So for our case, we have that one. So the app is misbehaving slightly. I don't know why. Or we can just use the other vertices. It will just give you the same. So we make sure the color is the same, the green color. So as you can see, we have two Escribed circles using the same approach that I've taught you, which is very easy. So we have this one, the Escribed circle touching this line. And then we have for the first one, the Escribed circle now touching the line J1, K1. So that is all for this. The second part was just to make you understand. So you should try to do more exercises so that you can have a better understanding of what happens in this uh, in these diagrams and what we have done. Of course, I think I've explained it too easily so that everyone can get you can see how easier it is to do all those things. So with the two, now you can understand that any any construction requires high precision and high accuracy. So that is the end of the lesson. Don't forget to subscribe, comment, and share to your friends. And also you can recommend your friends because I'll be uploading so many videos which can be helpful. And also, if you are there and you have issues with your SAT exams and uh, the KCSA and all the higher levels, the end of the high school, end of the secondary school, you can just reach out to me. And then I also offer tutoring sessions uh, to high school students, undergraduate students, and master students. So you just need to reach out and then we can plan how we can help each other using platforms like Zoom, Teams, and the Google Meet. Those are meeting platforms. So thank you. Have a nice time.